let's talk about the actual data, how it would look like in a IT system, right? And we're gonna first create the in table and paper. Now, obviously, even in complex implementations, first the things are designed. Of course, we use systems to design it again, but it is first designed and only then implemented, right? How actually data is stored in a database really depends on the database which you're going to use, whether it's going to be a standard rdbms database or a NoSQL database or a database specific to unstructured data. Now we're going to start off with the structured data, so we're going to assume that this is a rdbms regular database. Now, in this kind of a database, generally data is built into tables, right? Just like how you see here, we have tables. Tables have header, basically the column names, and they have the values specific to those columns. For example, if you have name, city, and age here, then you have the name of the person in the rows, the city in the rows, and the age in the rows. Okay, so the rows carry the actual value, and the header, which is the first row, has the names of the columns. Okay, so you will see this as you go along in this video. Now, each of this column at design time, basically when you're designing it, you have to choose an appropriate data type. Okay, so you discover in this session what are the different data types in a database which are regularly used. So for example, the name could be a varchar, the city also could be a varchar, and the age could be an integer. Okay, just to give you a quick introduction and to get you thinking as you go along. Let's try and take a look pictorially about how you would go about building data table in a database in perspective of the requirements and how you'd improve it as you discover more information. Okay, now let's say that you have students in a class, so you need to capture the information of these students, and you have a total of 26 students. Now imagine if you were to create a register which captures this information, basically a book which captures information. How you would go thinking about it? So what kind of information do you want to capture about these students, so that way you can draw the number of lines in your register, right? So you want parents information, address, contact number, blood group, height, weight, allergies, emergency contact, and things like that. Okay, so let's say that you want to start with just 3 pieces of information. You want the name, you want the contact number, and the blood group. In a register, these columns are constant, so right, so you can't just write a book inside that one specific tuple or one specific space. For example, let's say name, here it says it can have a maximum of 100 characters. Okay, contact number, maximum of 20 numbers, group, letters and characters. Okay, so it all has to come within this structure. Now if I actually go about populating this data, you will soon notice a problem. Now you see that you have Juan, Mark, Lori, and again another Juan, right? So there are 2 Juans, and one is A negative if you take a look at the blood group, and another one is B positive. So this is not good. During emergencies, this can create a lot of issues, right? So you need to identify each Juan with a specific unique identifier. Now that's what is a primary key. Okay, now if you bring in a roll number, then that problem is solved because these Juans are differentiated by the roll number. Okay, so you see that 1 2 3 4, 1 is Juan with a specific blood group, and 4 is another Juan with another blood group. Okay, so you do need a roll number. So I want to reiterate that each column has a specific length and a specific format. Okay, so that is primarily how you think about it. Okay, Now let's take a look at it from a database perspective. So now that you have very clear instructions as to what each of these columns should hold, now you can map it to a data type in a database, right? So the roll number only carries numbers, okay? So this is an integer, okay? Now it should be able to carry up to 35 students, so very well within the integer limits. Next is name. It should carry letters and perhaps up to 100 characters, right? So this is a varchar. This is the data type you would use, and also you would give the size as 100. Now it's a good point to say that data types, some of the data types come with constant spaces and some of the data type come with variable spaces, and these spaces are left to the designer to actually decide. Again, contact number is also an integer because all are numbers, and then blood group again is a varchar because varchar can take both characters, numbers, and everything in between. So it's a combination of letters and special characters, so varchar would be the choice here. Okay, so we're getting started with understanding how you would associate data types with real-time requirements. Okay, so this is the actual limit. Now again, this depends from different databases to different database. So varchar generally comes with 0 to 255 characters. Sometimes you can actually decide the value, and integer is actually a constant. This is the actual size of an integer. You can see that you can have numbers from minus 21474 83648 to positive side of that. Okay, so you can store a large category of numbers in an integer. Okay, now let's say that you want to expand this information. Now you want to add also the date of admission and the current GPA. Okay, so date of admission obviously is a date, and current GPA is again a decimal number. A 63.53 is a decimal number. Okay, so how do we map this with the data type from the database? For date of admission, it's going to be date, and for current GPA, it's going to be a decimal. Okay. Now all of these are structured data types. Okay, integer, varchar, time, date, decimal, all of these are structured data types. So these are the data types which you would see on a daily basis. If anybody is working with IT systems and are able to work with data, they will be seeing this data every day in terms of the structured data. Now let's take a look at the unstructured data. Unstructured data again is images, music, that is videos and audio, and books, perhaps reviews. All of these come under unstructured data. Of course, there is a place in between structured and unstructured called semi-structured. We'll perhaps talk about it later, but at this stage you can differentiate these two as structured and unstructured, which is a safe way to categorize them. So these have different formats, and they have specialized databases who actually store this information. So just to give you a very, very raw example, just like how we store different objects in a computer, for example, in your folder, you can have a image, a video, a Excel file, a CSV file, and whatnot, a movie perhaps. So your folder in your computer can store all these different kinds of data, right? So that's actually a very good example of how an unstructured database works. It stores all kinds of information in a specific file format, and then you have different specialized methods of retrieving different kinds of unstructured data and processing them. So what is the data type? Now, like I said, it's a file system, most likely. In a specialized unstructured database, it's a file system. But some of the structured databases, like for example SAP HANA and various other databases, they have a provision to handle unstructured data within a structured database, right? So they have a special data type for that, which is called as a blob data type. Now let's take another go at it. So stock price, this is structured or unstructured. Stock price is basically a decimal, so this is going to be a structured, right? So now let's bring in more information. So for example, a company stock ABC Inc. data type is going to be decimal. Okay, so that's how the stock price will look like, 125.75, and this should be safely categorized as decimal. Now CT scan, this would be what? Structured or unstructured? This is a image at the output or at how it is rendered, right? So it's going to be unstructured. And how it would look like, for example, in a hospital, you have an image and the data type is going to be blob, or if it's a unstructured database, then it'll be one of the file system, right? Great. Now, so now you have a little bit better understanding about unstructured and structured. Even at this stage, if you can just think about in your head as, anything which is structured is called structured data, and anything like images and videos and tweets and reviews, anything you can't kind of define and people can't comply with it, unless it's like a Twitter tweet which has to come within a certain set of characters, then all of that is unstructured. Okay, so even if you can't really put your hand on it, that's okay, but as long as you can put them in different baskets, that would be a great start.